Hey everyone, welcome back to Kitco Mining, coming to you from PDAC 2025 here in Toronto. Now, the global battle for critical minerals is intensifying, and you can tell in the room it's a huge discussion here. The U.S. has just imposed fresh tariffs, including a 10% levy on energy imports from Canada, and it's a clear signal that economic security is now national security. Meanwhile, China remains dominant in the critical minerals space, controlling the supply chains that power everything from battery to defense technology. But one of the most overlooked and one of the most valuable of these minerals is something called cesium. And right now, North America barely produces any of it. Now, cesium is one of the rarest elements on Earth, found in just a handful of commercial deposits. And it's essential for GPS systems, aerospace technology, the atomic clocks, medical imaging, and even really essential in oil drilling. Without it, entire industries can't function, and yet China already has a monopoly on the cesium supply. In fact, the last major cesium-producing mine in North America, Canada's Tanco Mines, was bought by a Chinese company. And that means every time cesium is needed in the West, it's coming from Chinese-controlled operations. But that might be about to change. There is a new globally significant find on the block. Patriot Battery Metals, PMET, just announced a major cesium discovery at its lithium project in Quebec, and this could reshape the North American cesium market. And it's not just another mining announcement. This could be a turning point in the race for critical minerals. Let's break it down. Joining me is Blair Way. He's the director of Patriot Battery Metals. Good to see you, Blair.
Great to be here.
Great to see you. We're here at PDAC. It's our 15th year covering this event. And, throughout the years, we continue to hear about gold prices being at all-time highs. I mean, we're almost jumping up to that today. We've seen the silver fight, not quite $50, but it's very evident that in this room, a lot of people are talking about critical minerals. Before we get into what PMET's doing here, I want to talk to you a little bit about China and their domination on critical minerals. It almost seems like everything that is cesium comes from there, or it's controlled by China, and that seems to be the case for a lot of critical minerals.
Absolutely. The critical mineral space has really been dominated by China for probably really the last 20, 30 years even. There was a time North America dominated it, but it became less in favor, and as lithium batteries took off, China built out the capacity to be able to really produce the majority of all the batteries and all the specialty materials required for them, whether it's the lithiums, it's the cobalts, all that feed into these batteries, the nickels. And now we're in a situation where all these dominant material, or very rare materials, are being processed in China, and we're behind. And there's an opportunity really for us to maybe get caught up. And as you say, some of the politics that we're seeing around all these specialty materials indicate that, having solutions in North America, and even more specifically in Canada and for us in Quebec, is a good thing. It'll be a good thing for the world market. It'll be a good thing for the Western world.
Yeah, that dominance in the critical supply. We see Donald Trump even trying to negotiate a deal with Ukraine to get some of their critical minerals. It's very topical at the moment. Let's go back to cesium before we get into the case studies, the uses of it, because I know some of the audience members might not know. Your discovery, the way that it's put out in the press release, makes it a real solution to the problem. It looks like one of the largest discoveries of all time.
It certainly is very exciting for us. Obviously, it's very early stage. We've already drilled out our CV13 discovery, and part of that drilling was obviously pulling the core out. We assay for multi-elements. Those elements, we obviously were focused on lithium. So we've been building a resource and have issued a resource for lithium. However, there are many other elements that we identified in there, and cesium was one of them, and majority of our holes are over limit. And what that means is when you test the holes, you test within a range. Maybe it's from 0.5% to 1 or 0 to 1%. You can't do the whole spectrum. So we have multiple holes that are over, or certainly indicate an over 1% limit. That is tied in quite closely to what we see at our high-grade lithium discovery as far as what we have identified. Many of the lithium assays were over limit as well, but of course we pursued them. So we've released our resource for lithium for the CV13 area, but now we've had a chance. That resource is out. It's with the engineers for a feasibility study, feeding the ESIA. Now the geos have a bit of time. They've gone back and we're looking at this, and it's like, holy smokes, we've got something really special here. We need to do the work. We'll come back and provide the market with more updates as we get that data. But as you said, the scale is quite impressive given the geographic layout. We've got a number of hundreds of meters in one direction and almost 500 meters in the other. So it's important and it has potential.
You know, we mentioned at the top, I mean, the Chinese have been controlling this supply for years. In the last cesium mine in Canada, Tanco was acquired by a Chinese company. Tell me a little bit about that. I mean, I think it's in Manitoba, and there's not I mean, in comparison, Blair, it looks like what you have is a lot more, and this is a large cesium operation.
It is the cesium operation right now, and they've actually not been underground mining. They do have pillars, and those are the pillars that remain to support the ceiling of the underground mine. They'd like to mine those pillars, but they can't without the ceiling falling in, so they're looking for solutions to mine that remaining stuff. They've actually been processing their tails because it was a lithium mine, it's a tantalum mine, and cesium. So what that really means is that they're not grasping at the last remains, but there's not a lot left there by the sounds of it. And what we think we've identified has that scale to be more than even what they've identified. CV13 is a big deposit area, and if our cesium is where we think it is there in the scale of it, I mean it's substantial. It has the potential for decades of supply.
And it's grade too. I mean, your highest grades are exceeding 9% CSTO, and you have over 140 assays still pending. I mean, could this be one of the largest discoveries in the world?
Look, we have to wait for the data to come in. Public company, you got to be careful what you say, but it sure looks like it. Just as I said, the geographic spread of it, we're looking at almost 700 meters one direction, a few hundred meters, 200 to 300 meters in the other. As we get those 140 plus over limit assays completed, we'll be able to present that picture, and ideally we'll be heading down the pathway of a resource on it. Now, the good thing is this is a byproduct for us. It's part of CV13. We've already drilled most of CV13 out. There'll be some more holes in the future to advance the quality or integrity of our resource at CV13 from inferred to indicated and beyond. But that infill program will also allow us to pick up the cesium. And of course, we'll be focused on it now because we've identified it as something of merit for the company.
I got to get your perspective here because the CV13 zone that you're talking about, it's estimated at around 280,000 cubic meters. Even using conservative estimates would translate to about 300,000 tons of material there. It's about $3 billion.
The numbers are staggering. Again, we have to demonstrate the accuracy to that. But you look at the scale, even 10,000 tons is big in the world of cesium. And the opaqueness of the market, who buys what and where, how big is that market? Is it 10,000 tons a year or is it 200,000 tons of pollucite? That's not completely clear, but what is clear, if there's more available, there's more demand because the military applications for it and other applications would be consuming it if it was readily available, which it's not. So it's sort of a double win.
I want to talk a little bit because obviously PMET is a lithium company and this is a byproduct. You found this. When did you think, okay, let's dive into this a little bit more?
Well, it really was. We're a lithium company. We've been delivering the CV5. We've drilled it out. We're taking it from an inferred resource to indicated. Now we're basically delivering a feasibility, which will contain a mineral reserve. That's all on track, and the geos have released the model to the engineers. They're doing the feasibility study. This feeds into the ESIA. So the geos actually had a bit of time to go back and look at some of these, and that's what you do. So it isn't just cesium. There are other quite interesting elements that are quite rare that certainly are worth considering in all of our assays, and we have over 200,000 meters drilled at the Shaakichiuwaanaan project. So there's a lot of data to go through, but CV13 stood out with the cesium. There's still lots of tantalum. We're looking at rubidium. I mean, there are many other things that we believe could be there, given the genesis of how we believe the cesium is shown up in pollucite. That's right at the end of the spectrum of as these deposits cured, shall we say. And if you can imagine, it's a bit like the further away you are from source, the longer time this has had to percolate and create with the right chemistry to produce the right minerals. And pollucite is that right mineral, and that's certainly what it's indicating to us. So there could be more specialty materials there as well.
Interesting. I mean, when we talk about the critical minerals space, and it really is a race, too, from China perspective. I know that the U.S. and Canadian government have both put cesium on the list of a critical mineral, so it's certified as such. Could you possibly see in this race, I mean, I know we're talking hypothetical, but some government backing here? I mean, there's a lot of eyeballs on these types of
look, we've only just put the news release out this week, but there's already quite a large amount of interest simply because of the nature of the rarity of cesium. So if what we indeed have identified comes to light, which we think there's good potential for it given the scale of it. The level of interest from the Canadian government and most likely from the US government could actually change the way we look at some of these materials, and maybe that might change the politics of some of the tariffs or whatever, because some of that doesn't make a lot of sense when you're in the industry, but eventually I think sense will prevail, but things like this can certainly help that.
I'm curious about the economics of the deal. I mean, nothing changes on your lithium front. It was still one of the largest properties, the Corvette over in Quebec. Just adding this to it, what does that do to the economics? And in terms of the timeline too?
Certainly, as far as the economics, it certainly has the potential. Again, I'm going to use the word potential because I have to be careful how I characterize what we believe we've identified there. But if it is the scale that we think it is, it's next level potential. Like it's a byproduct, yes, but it's a very significant byproduct. And again, as depending somewhat on how the market develops from it, given that it would be more readily available, but it would be significant. How it ties into our production scenario, we still got to work that out. We are definitely producing a feasibility study at our CV5 deposit. That's our focus, that's the ESIA, but we are able now, with our geological team being a little bit freed up, we can look at these, both cesium and some of the other interesting elements we have there, and see how that can then be tailored into the development site.
Yeah, that's what I was wondering, with this news. I mean, could you see that standalone resource estimate just on the cesium side or feasibility, like you mentioned? You're going to put some energy and focus into that?
Yes, so the work, we can now do the work on it. As I said, the geos have that time. We'll start doing the analysis. We'll have to go with the labs. The labs will do their over-limit testing. That's probably, a few weeks away, even a month or so. But once we have that data, we can build a model very quickly. It's, as I said, it's not a new area on our property that we've just kicked over a rock and said, hey, there's a bit of cesium there. We've drilled it. We have over-limit assays on over 100 holes. We'll look at those over-limits and see where they come in. But even if they're only 1%, it's still significant given the scale.
Significant, yeah. A lot of people mumbling about it here at the show. Congratulations, my friend. Well done.
Thanks very much.
Thanks for watching. I'm Jeremy Saffron here at PDAC 2025. We're going to have some great guests coming up all week long. Make sure to hit the subscribe button, and we'll see you next time.